Okay, I don't know how much background noise there is, but I'll try to make this video. Now, what we're going to do is we've got some. This is if you haven't seen a couple of the earlier ones, we've got some data on the loan. We've got some data on trying to measure industry risks, management risks, and we've got some financial ratios. We put it together in this Shift Control 7, Control B, in this allocation. Okay, and the various different factors come from. People are trying to interrupt me while I'm making a video, which is horribly irritating. They come from these other sheets. Now, one of the primary sheets is to do a whole IRR analysis. We start by just putting all in the parameters of the loans. We make sure that we can make the loans operate with either monthly, annual, or semi-annual, or quarterly payments. I suppose I could have put monthly in. And then we first get just the regular IRR on the loan, and then we split that IRR up into the cost of funding component and the risk premium component. Now, what we're going to do in this video is fill in the implied probability of loss. Now, in the last video I made, we said, okay, well, why don't we just take the present value of the risk premium and divide that, which is this number, at the funding cost, and divide that by the NPV, the balance of the loan. And then we get this percentage. Well, when you look at actual probability of defaults and years, there's this nice little table, which is, I find, more convenient than the others published by Standard & Poor's. Whether it's true or not is another story, but they give you the probability of defaults, and these are the cumulative probabilities. Okay, now if we what we could do is use this data to compute the probability of loss in the way Standard & Poor's or Moody's compute it. So we have a basis of saying, well, what's the real implied maximum probability of loss? That's the first thing we're going to compute. And then we'll do it a little bit differently. We'll take the same thing. We'll take this risk rating and put it together with the probability of the losses and figure out what the probability of default should be from these tables. Okay. Now, once we have I'm going back and forth, and I apologize for that, but you can find this file. I told you where I'm going to put this file. I'm going to put it, how about I'll put it, I'm certainly going to put it in this financial analysis section. I'll put it in a featured acquisition model too, because you use this in acquisition models quite a bit. Okay. And then now, once we have the probability from the risk rating, now I've just shown you how generally we'll get that. Then we can take the risk rating and get the capital allocation from the risk rating as well. And that's kind of in this sheet, which just says, this is kind of simple. It just goes through the kind of standardized risk ratings This is kind of a good one, I guess, but this is government, this is investment grade. Ah, shit. Yeah. This is what I understand the kind of criteria for capital for different kind of loans is. Okay. Let me put that in. Now, to do all of this, here's some of the tools we're going to use. We're going to have to use the interpolation again. We're, of course, going to use match and index a whole bunch. We're going to do some cash flow analysis on in the IRR sections. And we will, we're going to use a dynamic. Oops, there's the dog. Okay, so now let's go and begin. Now, to begin, let me just show you the different sheets. I hope they're organized just a little more better now. This is our IRR analysis that I just showed you. Our loan inputs, we allow different inputs to be entered. You know, you can make them a mess over on the side and then put the parameters of different loans. And we selected this customized loan instead of one of these other loans, so we can play with it. And then we have again this line here. This is the line that goes into this page. Maybe one day I should make a macro that colors based on which page it goes to rather than which page it comes from. This is the same kind of analysis where we put different industries and put different weightings and different factors in different industries. That's such an important kind of thing to understand. There will be upcoming videos that go through some rather theoretical kind of analysis of how to look at volatilities and capital intensities and differences between long-term and short-run marginal costs and other factors that really drive this stuff. Then this is the earlier stuff we had, which says, okay, let's take this business risk and ratios, these shift control 7, they come from the other sheet. Now, I have to obviously press shift control C again. Oh, this didn't come from that, yeah. And this didn't come from that because it came from other ones, but you can kind of put this in different things, and that's how we get this. We use the interpolate function a lot, and we get the risk rating. Now here's where we are in this one, and let's, if I press shift control C, because generic macros are open, these are the inputs. We get some of these. Now, this is so boring to do, but I'll put index. As soon as I have a table like this, it's almost automatic kind of reaction to say, let's put a code number and an index in, and then we can make a graph. Now, if we make, well, let's just make a graph like this. Alternate F1, make it a little smaller, and okay, and perhaps we can, I don't know. How about let's try, let's try to select a chart type. I don't know. The XY scatter really won't matter, but we can put this, and then we can try to fit a trend line to this. Okay, it's not going to fit a perfect one. I'm going to just fit a linear one for now. And let's display the equation. We don't want to set the intercept, we want to just display the R squared. Okay, I guess we have to put an X out of this one. And we can 2 and 3. Now, if you would like to kind of see what the how to get the statistics, you put line LIN, line estimate, and we want to make this the x-axis, this the y-axis, so this will be a very simple, and you put 2 commas. That's because we don't want a constant, and then you type true, and then you press Shift Control Enter, and this is the coefficient. Somebody who wrote this function didn't really do that well. This is the standard error. This is r squared, and I don't know what's after that. And this is like the sum of squares of the regression or something, and this is degrees of freedom. So if we, take this divided by this, we can get the t statistic. Okay, and this says that this is the intercept, and this is the slope. And you can also, if you wanted to get the slope, we could also put equal slope. And we can put the known y's first here, and then the known x's. So when I think when I write this up, this is slope, and then intercept. You just do the same thing, intercept. I think it's not that bad. This criticism that Excel sucks. On my disk, I have, in the old days, I used to do a lot more statistics, and you could come up with programmings and do some functions and do some macros, or do some just regular old adjustments to make them do autocorrelations and all this sort of things. Okay, so we can, how about let's look at the slope, Shift Control 7, Control B, and then we can kind of look at what happens to the slope if it's AAA, AA, A, triple B, double B. Triple B is kind of the one I like to focus on because it's kind of in the middle. Okay, so I don't know if that helped much, but then now I oh, there's the dog again. Okay, I'm going to redo what I did here. Okay, we have another code number. Okay, I'm going to leave the code number. How's that? Now we want to interpolate from 5 to 15. All we do is put equal interpolate linear, and then we say I want to use this one. Now I've got to press F4 a couple of times because I'm just going to keep the row number, and then we can just I can't do that. I should have been able to do that. F4, and then we put this in. No F4. And Shift Control R. Did that work? No, it didn't. It went 1, 2, excuse me. Okay, just a minute. Okay, I switched the video off in the wrong place. That was really stupid. I don't even know how to turn it on and off. I'm going to remake this interpolate function. You put equal interpolate linear. Okay, and you go up to this one. Now press the F4 key on the row number, not on the column like I did. Lock in this entire thing, and then go up to the first row, and then press F4 to lock in the whole thing. But you don't want to lock in the rows, you want to lock in the columns. That's what I did wrong. Shift Control R, and we get the interpolate to work. Okay, I hope I did the statistical thing before I switched off the video. I think I did. Okay, and then now as a natural reaction, I hope you just say, oh no, I gotta quickly put an index function in here, and press Shift Control R, Shift Control P. Okay, now let's show you kind of how this really works, and I don't know why people don't do this more. We're gonna use this probability of default to kind of make a little simulation about what can happen. So let's say we have a 6-year loan. Let's say a loss given default is 100%. So these probability of losses now are the same, probability of defaults are the same as losses. That's not really true. And then let's go and make a little period counter, okay? Shift Control R, and now we'll make a little switch now. This is the second time I'm doing, so it's a tiny bit more efficient. Okay, so that's just going to count whenever we have true. You can see that there are a lot of similarities. Let's say we have negative 450. Oops. I don't know what in the hell. Shh! Stop barking! Oh, shit. Oh, God. Okay. So, okay, hopefully the dog has stopped barking. Ah, shit. Where was I? So this is, we take this and multiply by the switch. That turns off the cash flow. So this is a 6-year debt, and our IRR with no default on that debt would be this amount, and that could include the fees and everything else. It's a little high, so let's make this minus 500. Okay, and it's still pretty high. But now let's say we have a loss on the debt. So let's say it's a BB loan, and we have this. This is our default in year 1. So that's how much we lose. If we have only a 1-year debt, we get 90 whatever that is, 98.9 or whatever. And if it's in the next year, I assume we'd lose the first year, and then we'd have another loss. Okay, well, maybe I don't know exactly how they measure this. So, and by the 4th year, out of our 100, we've lost 11. Now, the problem is we could recover some of this, so the recovery is just the loss 1 minus the loss given default. You can see that we're really always applying the same kind of principles. This time we have no, you know what, I'm going to put this loss, let's just make sure that everybody knows this is a loss, and put a minus here, violating the positive number convention. And then we can put our net cash flow as alternate equal. And then we can put IRR. And then then we can put our minimum required spread. Okay, and that's just the difference. So if we have a double B loan, we need at least a 2.04 credit spread. Now, if it's the loan is 7 years, we need a 2.1. If the loan is a even worse loan, we need a 5% credit spread, much lower than the credit spreads really are on these kind of loans. If we have a triple B, we only need a 0.5%. We don't need this kind of 1.5% standard that you see. Now, if we have a 1 year, well, let's make this minus 90. Whoops. 5. We kind of could do some sort of goal save. We only need a 0.21 credit spread, but if it's a 2-year loan, I'm putting up minus, let's say 190, and we need a 0.31 credit spread. You can kind of see how the credit spread is adjusts depending on the length of the loan. Now what this really shows you, and this is with 100% loss given default. If we have only 60% loss given default, then our credit spread goes down. So you can kind of see the credit spread. If it would just be a 1-year loan, it really is kind of the probability of loss times the loss given default. Those are the two things that drive it. Now, okay, so let's go to the next step. The next step of this is to incorporate this whole analysis into our other analysis, our IRR analysis. Now, what you could do here is you can look at the increase, the percent increase. How much does the probability of default increase over time? And if you take this divided by this minus 1, that's the percent increase, shift control R. And if it's triple B, you can see the percent increase, how much the cumulative probability increases over time. If we have a 5, the pattern's a little different. If 1 didn't work with zeros, 2 it didn't work with the first zeros, 3 it's 100%, 3 is A, 4 is triple B. So I'm going to use this. Now, when I use this, here's what we'll do. We'll go to our IRR analysis, and then what we're going to do is essentially put in let's say we're going to put in a loss given default, a probability of default rather, that implies, that has the same, that results in that results in a IRR on the loan that's equal to the, after we adjust, it's equal to the cost of funding. Okay, so here's what we can do. We can say, well, the period of the repayment is just the last period plus the repayment switch. Okay, so that's why it's 0 at first. Okay, and then we can use another thing, if just in case this isn't in years. Right now it's in years, but let's say it's in semi-annual periods. So we put this down to here, and we need this in years because the S&P analysis is in years, so we put round up, and then you go to this one, the year, and you divide it by not the 6, but divided by the 2, and then you put a comma 0. And what that will do is when it's 0.5, it'll always round it up to 1. When it's 1.5, it'll round up to 2. So right now you have 2 1s, 2 2s, 2 3s, 2 4s, 2 5s, and so on and so forth. So that's how you switch the period to the year. And then if we want we can then just use a lookup function, I hope, and look up on the year. That's what we really need. And then we look up this entire row, and then we look in the second one. That's how we use the lookup function. We've got 2 NAs. Doesn't really matter, but then we have to adjust these, because if it's semi-annual, we'd have to divide them by 2. So why don't we put if this thing is greater than, oops, if this is greater than 0, then we'll take this one and divide it by the 2. Otherwise, we'll just put in 0. We could have used some if error. I might have used an if error when I did that before. Okay, so that gives us our percentage increase. Now, if we just put in some fixed default probability, let's say it's 2%, okay, then we can say, well, let's take, oops, and here's what we need to do. We want to do it if we want to just have the starting point. Okay, so how about we'll put if not this one. So if this is false, then we'll take this, fix that. Otherwise, we'll go back and multiply that by 1 plus the increase. Okay, now I think I did that a little bit wrong. Okay, so we go in period 1, it's our base period, which is 2%, and then after that it goes up here. Just a minute. It should be staying, oh no, it should be staying at 4.5 for those 2 things. Why did that? We just a minute. I was just thinking what the best way to do this and keep it simple, and I can't think of a good way to do it. I'm sure there is. If that's great. If we'll have to put an and here. If this is greater than 0, and I hate this month of the very first period, F4 equals the month of this period without the F4, then we do it. Now, oops, I need come on, well, I'll do it again. Okay, if we're going a little bit slowly here, this comma month of this first period equals a month. Okay, So what this will do is it will only put the increase in the first of the year. Okay. So this shouldn't have worked. Month of L. Where did L2 come? Okay. So now we fixed our probability of default and have it going up. Now the loss given default, Shift Control C. Hopefully that came from an input, and if you really look at this carefully, you can see that now that has a different color. So our realized cash flow is I'm not going to, how about this? This is the realized debt service, is the debt service we compute from all our loan analysis, and we reduce it from the default we realize, and then we put this net of the loan, and then we have our IRR realized, and we can put our cost of funding, and what we need to do is get at least an IRR that's sufficient to cover our cost of funding, so we can just make a data and what if analysis and make a goal seek, and let's set this to 0 by changing the this one. Now, in what this is a horrible thing, really, for a few different reasons. Well, this is not very important that it didn't match exactly, but now we can, this is this kind of maximum implied probability of default, and I suppose, oops, I put the wrong one in here. Oh, I'm sorry, it's not that yet. We have to do one more step. Now, if we look across and we go to the year in which, the very last year in which we had a default, and we can see, oh, this credit spread is equivalent to allowing to being safe enough to cover a default of 40.55%, and we still get this paid back. So I'm not sure why this didn't work, but if let's go, and we want to go to year 22, that's when, or period 22 rather, and we want to find the first period 22, so we'll put equal match, and you know, it would be a lot more, I'll put periods, just so we are very transparent with this whole process. And we put our repayment period, and then we put equal match. And we put this in, and we click on all of the periods of repayment here, not the years, the periods. And we put 0, okay, and that gave us 30, the column number 30, and then we put index, and we click on the probability of default line, That's what we're really looking at. It's kind of wrong when I said it earlier. So this is equivalent, or this credit spread is equivalent to allowing a 68% probability of default. Okay, now I think you could right now make two options. One option is if we change this with our spinner box, every time we change it, we run the goal seek. If we change this customized loan to something, we just run a goal seek macro. And if we change our loss given default, we run a goal seek macro. That's option number one. Option number two, which I think is much better, is to make it really dynamic. Make a dynamic goal seek. Now this video is long enough, so I'm going to stop it. And in the next video, we'll show you how to implement those things. All right, so that's it.